Okay, so now we'll move to next load combination, that is load combination 2. Load combination 2. So what is second load combination? 1.5 into dead load plus wind load. So dead load plus wind load is the second load combination. So by using the second load combination, we have to calculate x direction load for second combination. So now 1.5 into, here we have to add wdx plus wwx. So here wdx is again 149.56 and wwx is a 0. wwx is a 0 and wdx is a 149.56. So now tell me this value in Newton per meter, second load combination. 224.34, 224.34 Newton per meter. Okay, and next load combination, the sorry, next, due to second load combination, y direction load is a 1.5 into w dy plus wwy. So 1.5 into wdy is a 299.19. Now here wdy value is a negative, and this is how much? wwy value, wwy value is a 1495.99. 1495.99. So how much this value in Newton per meter? I think it may be negative. The value will come in negative sign. How much? 1795. Sadiq, your answer? Ah, yes, correct now. So it will be negative 1795.2. 1795.2. So now load combination of this dead load and wind load with y component is a negative 1795.2 Newton per meter. So this is the second load combination. So now we have to go for the third load combination. So third load combination 3. Load combination 3 is the 1.2 into dead load plus live load plus wind load. So we have to factor by 1.2 for this addition of these three loads. So now wx3, x load in x direction for third load combination is now here wdx plus wlx plus wwx. So 1.2 into wdx is 1.49.56 plus wlx. wlx is how much? wlx is 348.98. 348.98 and wwx is 0. So now tell me X direction load due to third load combination. $598.24. Yes, correct. 590. Sadiq, is this 595 or 598? कोणाचा आन्सर बरोबर आहे? Priyanka, check your answer. Is this 598 or 595? Sadiq has given 595. So Swapnil has given 598. Please check. Sadiq, your answer, please check. Yes, correct. 598.24. 598.24. Okay, got it. Correct. So 598.24 Newton per meter is the X component load due to third load combination. Similarly, WY3. So 1.2 into again WDY plus WLY plus WWY. So 1.2 into WDY is 299.19 plus WLY. So WLY is 698.13, and here WWY is negative 1495.98. So tell me the answer, whether it is positive or negative. Minus 598.4 minus 598.404. Yes, correct. Swapnil, Priyanka, yes, correct, your answer. Both are same. Okay. So these are the now 6 components with 3 load combinations. Due to load combination 1, you can see now here. So due to load combination WX1 and WY1. Due to second load combination WX2 and WY2. And due to third load combination WX3 and WY3. So now by using these 6 load combinations, we have to find the critical load combination now. So now critical load combination. Write down. Now critical load combination is in X direction and in Y direction. Now which is the maximum load in X and Y? Don't consider sign, only the consider value. X direction maximum value. Which is X direction maximum value? See here. X direction maximum value is 747.81. 747.81. Okay. So X direction maximum value is 747.81 Newton per meter. This is the X direction critical load coming on the Purlin. Now Y direction critical load. It may be negative or positive. Don't consider sign, only tell me the maximum value. So 1795.2. 1795.2 Newton per meter. So X and Y critical load combinations are X is the 747 and Y is the 1795.2. So here this negative sign indicate the uplift pressure. So don't consider negative sign while selecting the your maximum load. This is load. It may be negative or positive. Negative means uplift and positive means downwards. Okay, so these are the two critical loads we got. Okay. Okay. So here if we not consider this sign, then no problem. This will be only uplift. Okay. So now this is step number 5 over. Now step number 6. So step number 6 is calculate biaxial moment. Calculate biaxial moment. So the first moment is the mx. First moment is the mx. So mx we have to calculate w y l square by 10. So here what is L? As I told you, L is the here spacing of truss. So Wy is the 1795.2 into spacing of truss. Spacing of truss. So truss is spacing of truss is 4 meter. So 4 square divided by 10. So tell me the moment in x direction in Newton meter. Similarly, calculate the moment in y direction is wx into L square divided by 10, 2872.32. 2872.32. 2872.32 Newton meter. Similarly, calculate moment in y direction. So 747 into 4 square divided by 10. So how much moment in y direction? 1196.49. 1196.49 Newton meter. Okay, got it. So these are the two biaxial movements we have calculated. Okay, so now we have to go for step number 7. Okay, step number 7. Selection of angle section. Step number 7 is selection of angle section. So first we have to select the width of angle. So width of angle is, it should be less than L by 60. As per our statement, the width of angle should not be less than L by 60. So here, so L by 60. So L is, what is L? Again spacing of truss. So here spacing of truss is 4000. 4 meter is, it means 4000 mm. So 4000 divided by 60. So how much it will be? 66.67. 66.67. It means we will assume 70 mm. So width should not be less than 70 mm. Similarly, second, depth of angle. Similarly, we have to calculate depth of angle, and that depth of angle is should not be less than L by 45. So here L is again 4000 divided by 45. So how much depth of angle? It should not be less than this value. 88.89. 88.89. It means we'll assume 90 mm. So our width should not be less than 70 mm and our depth should not be less than 90 mm. So that criteria we have to follow for selection of the angle section. So by using this width and depth ratio, we have to select the angle section from the steel table. So now we have to go in this steel table. See, so now go to steel table. So now the width of the angle should not be less than 70 mm and depth of the angle should not be less than 90 mm. That minimum criteria we have to follow, and as per your wish you take the thickness. It may be 6 mm, 8 mm and 10 or 12. So here we will select, write down, we will select here, select ISA. Everyone please go to this section, select ISA 100 by 75 by 6. We will select the angle section 100 by 75 by 6. So 100 is the depth, 75 is the width and 6 mm is the thickness. It means width should not less than 70 mm and depth should not less than 100 mm, sorry 90 mm. So here instead of 90 we have used here 100 and instead of 70 we have used here 75. So this section we will select from the steel table because this is available section. जो सेक्शन अवेलेबल आहे तो सिलेक्ट करायचा. Otherwise here 70 and 90 values came here, so you will select as you wish 90 by 70, but you have to select this section is whether available in this table or not, because we have to find the properties again, ixx cyy, that properties we have to find from the steel table for further calculation. So we have to see in this steel table and we have to select the section. So here 100 by 75 by 6 section we have selected. Now what is next step? Step number 8, classify the section. Classify the section. So for width and for depth we have to classify the section. So first W by T and here D by T. So W is a 75 and T is a 6. So how much this value? Here depth is 100 divided by T is 6. So how much classifications is there? So 75 by 6 is, so it should be I think 9.4 and it should be I think 84. So this is I think plastic, this is again plastic. So tell me both answers. 12.5. This value 75 by 6. 75 by 6 is how much? 12, 12.5. So here, okay, so 12.5, it means uh, it means less than 15. 16.67, this is 16.67. So this is plastic classification. For depth, the classification is plastic, and for wave or width, I think this is semi compact. Correct. So this is the classification. Now step number 9. So step number 9, calculate plastic modulus. Plastic modulus, it means we have to calculate ZP. So ZP is equal to Ix6 divided by I max. So Ix6 divided by D minus Cyy. So now again go to steel table for the section 100 by 75 by 6 and find the moment of inertia Ix6 for this section, and again Cyy value. So tell me, I don't have steel table, please tell me these values. How much value of Ix6 and Cyy, tell me. Ix6 100.9. Ix6 value is 100.9 into 10 raised to 4, and Cyy value, D is here 100 minus Cyy value. How much Cyy value for this 100 by 75 by 6 section? So Cyy value is 1.78 centimeter. It means 17.8 mm. 17.8 mm. So calculate here ZP value by this calculation. Similarly, we have to calculate ZE value. So ZE again Ix divided by Y minimum. So Y minimum is a Cyy. So here 100.9 into 10 raised to 4 divided by Cyy is again 70.8. So tell me this both value ZP and ZE, plastic section modulus and elastic section modulus. So first tell me the ZP value. So ZP is a 12 to 74.93, 12,274.93. एवढंच आहे का एम इंटू 10⁻³ वगैरे आहे? ओके, एवढीच व्हॅल्यू आहे. And ZD value, okay, do the calculations fast. 56,685.39. 56,685.39. Is this correct? 56,689.39 mm cube. काय चुकतंय का? Okay. So this is the step number 9. Now step number 10. Step number 10 is calculate design bending moment or design moments. Calculate design moments. So we have to calculate mdx and mdy. So here instead of 89, 85 is there. 85.39. So now step number 10 is calculate design moments for the our calculated angle section. Okay, so how to calculate mdx? So mdx is equal to, the formula is beta b into zp into fy divided by gamma m naught. So here beta b. So for semi-compact section, how to calculate beta b? So for semi-compact section, beta b value is ZE upon ZP into ZP into Fy divided by gamma m naught. So for beta b value, beta b is equal to ZP upon ZE. Sorry, ZE upon ZP. ZE upon ZP for semi-compact section. For semi-compact section, beta b value is ZE upon ZP. So here ZP will get cancelled. ZP will get cancelled. So now calculate ZE. So ZE value is 56,685.39 into Fy is 250 Newton per mm square. Gamma m naught is 1.1. So tell me the value of mdx, and it should be less than mx. So tell me fast answers because our time is closing. Okay, so mdx is 12.88 into 10 raised to 6. 12.88 into 10 raised to 6. And how much mx? How much was mx? So mx is 2.87 into 10 raised to 6, I think. 2.87. This is MD8 is 2.87 into 10 raised to 6 Newton meter. Or mm. So convert this answer into this Newton. This is mm cube. This is Newton per mm square. So this is Newton mm, and this is Newton meter. So it means 2.87 into 10 raised to is this answer is 10 raised to 6 what Newton mm, and this is Newton meter. Sorry, this should be greater. This answer is greater. Similarly, calculate now mdy. So mdy is equal to again 1.2 into ZE into Fy divided by gamma m naught. So here again 1.2 into 56685.39 into Fy is again 250 divided by gamma m naught is 1.1. So how much this? This is again greater than my. So again my is 1196.49. So tell me this answer. And next step is step number 11, last step. Check for biaxial bending. Check for biaxial bending. And so check is mx divided by mdx plus my divided by mdy. It should be less than 1. So how much value this mdy? So mdy value is 15.45. 15.45 into 10 raised to 6. It means this is again greater. So now take check. So convert these values न्यूटन मीटर मध्ये कन्वर्ट करा. So this value is 287 2.32 287.2.32 divided by 12.88 into 10 raised to 6 plus my is 1196.49 divided by, if we convert this in Newton per meter, 2.87 into 10 raised to 3, and this value is 1.196 into 10 raised to 3 divided by 15.45 into 10 raised to 6. So how much this value? How much this value? It should be less than 1, less than or equal to 1. Do these calculations fast. Only 1 minute is remaining now. Tell me fast. Less than 1. If this less than 1, hence safe. Tell me this first answer. Only 45 seconds are remaining to close our session. I have taken your attendance also. If sessions close, please do not join. But tell me answer first. So here we will end our unit number 7, root truss. So next lecture we will start the unit number 8. Some taken answer.